expressions by collecting like terms. That is our objective. That's what we want to be able to do. Have you written that down? Go for it. I would say an expression is, right, we could say it's an instruction of what to do, okay, when you know the numbers. Now that might seem a little bit vague, but I'm sure those people from yesterday think, oh yeah, we talked about that, didn't we? You know, what happens if you put the numbers in. So an example of an expression would be, well, does anyone want to give me an example of an expression?
10x divided by 14y.
Or should we just do 10x plus 14y minus 2x plus 8? Just keep it nice and simple, yeah? All right. Now we had a name for this kind of expression. All right. This is a what?
Wait, no.
Standard?
No.
Unsimplified.
Go back to the very beginning. It is unsimplified.
I think.
Is it a monomial? Is it?
Oh no, that's a polynomial.
Good. It's a polynomial expression. Do you all remember why it's a polynomial?
Because there's more than 3.
More than 3. So if it's one part of it, it's a monomial. If there's 2 parts to it, binomial. If there's 3 parts to it, trinomial. If there's more than 3, a polynomial. So if there's 4, there's 5, there's 6, we have a polynomial. This is a polynomial expression. Okay. This expression has how many terms? 4. Has 4 terms. Should give myself more space. What is a term? Okay, so a term. A term is part of an expression. Okay, and we can say separated by addition or subtraction. So, Andrew, when you said about doing an expression which was 10x divided by 14y, the reason why I didn't go with that is because that would only have been one term, because division and multiplication don't separate terms. All right? So let me just make that clear, I guess, here. So 10x plus 14y, 2 terms. 10x divided by 14y, 1 term. Okay? So it's got to be separated by a plus or a minus, not a multiplication or a division. Why not multiplication? Well, 10x is a multiplication, right? But it's only 1 term. Written that down? Stay focused. So a like term is, let's say, 2 terms where the variables match exactly. The coefficients can be different. What's that word I've just used there, the coefficients? What do you think that refers to? The numbers, okay. So, What do I mean by this? Well, 3xy squared and minus 2xy squared are like, okay? But 5ab and 5a squared xd are not. Okay. So the bit that we're looking at is like you've just been saying. You say the ending, and that's because we put the numbers first. Don't we? Remember what I said? 5 is not what?
A variable.
True. But I said one way to think about this, 5 is not actually a, but therefore a 5. 5 is not a 5 in this case. What is the 5?
It's 5 times A, B, C.
Yeah, it's how many A, B's and C's I have, right? So it's not a 5 in its own right. Whereas if I said to you, we've got 13 and 16 are like or not like? They're not both variables. They are constants. Okay. They are constant terms. Why is it constant? Because it never changes. Now that is a 13 because it's on its own, yeah? It's not saying there are 13 x's or anything like that. So, we are going to use this information about terms, expressions, and like terms to be able to simplify expressions by collecting any like terms together. Right? So that's what your assessment was about. So girls doing it yesterday, do you remember, did you get the idea of what like terms were?
Yeah.
Does this seem like you were saying the right stuff?
I thought I think I'm correct.
Okay, so let's have a look. We've got a couple of things here. Are we not finished? Do we need to?
I'm just.
Let's look at. So we've got two expressions now. We are going to simplify them by collecting the like terms together, and we need to work out this whole standard form thing, which wasn't in the assessment, but we did talk about it yesterday. So let me run through the first one with you. So I'm going to follow a trick. Well, Holden did this in his assessment. I'm going to use highlighters. So I'm going to highlight the like terms in different ones. So does 7x have a like term?
Yes.
X. So I'm going to highlight 7x and the plus an x. Alright? Notice how the plus comes with the x. It's a positive x. Oh, I'm messaging me. What I'm then going to do, I'm going to highlight anything else. So I've got minus 2y's is like with minus 6y's. Now the sign goes with the term that follows it. That's important. Alright? What's the sign that goes with the 7x? Is it a positive or a negative? It's a positive. Now if I want, I can add. Alright? But we don't have to. I'm now going to rewrite it. So I've identified my like terms. Now, you can do what I did, which is highlight. What Holden did was he drew boxes around one lot and then underlined others to show. And some people do triangles and circles and just depending on how many they've got. Now, that's up to you how you want to do it. Right? What I'm now going to do is rewrite this with all the like terms collected together. So I'm going to say, well, this is 7x's plus the x, that's why the sign goes with it. It's not a minus because of the minus after the 7x. That minus goes with the 2y, and then I've got minus 6y's. Okay? And then we do what one of you said in your assessment, which is we get the answer. Who's that? We get the answer. And what we mean by the answer is we actually, now we can decide, well, what is 7x's plus 1x? How many x's do I actually have? I have 8 x's, right? Hold it. Stay focused. And then, remember the sign goes with the term. So I'm actually at negative 2y's minus another 6y's. Do I end up as a positive or more negative? Where do I? This is where your work on your negative numbers has to come in. You see, that's why we did it. That's why we focused on it a lot. So you should now be quite good at saying, well, I'm at negative 2. All right, if I've got my number line, all right, if I'm at negative 2 and I subtract another 6, which way do I go? Down. Down 6. And I end up at negative 8. Good. So I end up with, these two become negative 8y's. And that is simplified. That's done. But what I'm going to do now is I am going to tell you, and you can write this down, a common mistake, because it's always good to see potential mistakes so we don't make them. We know what the mistakes are. Does anyone know what a common mistake could be? Actually, we get to this point correctly and then we go further and make a mistake. What could it be?
If somebody did 8x minus 8y.
And what do you think they could give an answer as? Well, actually, they would do 0 x, y.
Oh.
Well, do you know what is great? Every time I go through this, people go, what? That's silly. That doesn't make sense. Why would they do that? Because I know exactly why it's not right. And then when I do an assessment, I'm going to do exactly that. And then when I say, why did you do that? Oh, well, I thought you could do that. But in class, you were looking at it going, that's silly. So that's why I say this. But why do you think they did that? What do you think their reasoning is?
They think that they're trying to answer, like they might read the question wrong or something, and they might think they have to answer 7x plus x plus 2.
Yeah, I think it's not even reading the question wrong. Some people think I have a thing in the paper in a maths book, I have to give a final answer. Yeah? Where simplifying is simply that, simplifying, right? Why do you think they've got a 0?
8 minus 8.
8 minus 8 gives 0, right?
I just said 8 minus 1.
That's wrong, but it makes some sense, right? Girls at the end? That is wrong, but does make some sense. Why does it make some sense? Because 8 minus 8, okay, 8 minus 8 is 0. It is completely wrong, but it does make sense. But what doesn't make sense is just to put the x and the y together. There's no reason to do that, is there? There's no reason. But yet people do it. Because they think when you simplify, you basically just collapse everything together. Alright, you write one term, which is not going to happen. This is simplified because we go from 4 terms to 2 terms. Exactly. Simplify, we should write this as a, to simplify in maths means to reduce the number of terms. Simple as that. To reduce the number of terms. It doesn't mean give an answer. Sometimes reducing the number of terms gives you a final answer. right? But sometimes it doesn't. If I've got variables, I can't do a finite. So this is, by the way, make it very clear in your notes that that is a common mistake, not a correct answer. Yeah? Make it absolutely clear that that is not correct. This is correct. Okay? This one is, why did I do that? Alright? Now I say this every time, and unfortunately I get proven true. At least one of you will do a mistake like that in your assessment.
I did something like that. I did.
No, I don't mean the one you've just done. That'll be understandable because you've not been seeing it. But in the next assessment, having already been taught it, someone will still do it. Alright? That's my prediction. I hope I'm wrong, but I've always had at least one. So some people did that in the one they've just done, yeah? But that's alright, because you're learning. That's why it is a form. Alright, can I get you then? Have a go at that one yourself before I let you get on with the exercise. So what would this one be? Right. Let me just, I'll take a photo. What do you think the simplified form of that? How many terms will be in the simplified one? You tell me. Okay, let's have a look. Hopefully you got it. So I'm just going to go through. So I've got 40 cubed. Is there a like term to 40 cubed?
10.
It's not 10, it's negative 10. I'm being a bit fussy, but that's why Rory made his mistake.
Oh,
It's a negative.
10.
And then there's another negative t cubed. Okay?
Oh, no, minus 2. Oh.
You've got to take the sign that comes before the term. So then we've got negative 6r plus 9r. They're already together. That's nice and easy. And then there's just a nice plus 7 on its own. Alright? So my next stage is to write out those together. So I'm going to do 40 cubes minus 10t cubes minus another t cubed minus 6r's but plus 9r's and then plus 7. So now I'm going to do the answer, as some people say. What is 4's? 4 of them, take away 10 of them. Negative 6. Take away another one. So it's negative 7 t cubed. I've then got negative 6r's plus 9r's. So negative 6 plus 9 is positive or negative? Positive. So I'm going to do positive or add 3r's and then just plus 7. Okay. I have gone from 6 terms to 3 terms. Now, one thing we should add that we've not had to worry about with the previous one, this is in standard form. Why is it in standard form? Does anyone remember?
Because it's
Because it's the exponents being added
Yeah.
together. I mean,
Put the exponents in order highest first. So we've got 3, that's a 1, and this is no exponent. So this is why that one goes first, this one goes second, the constant always goes last because it's got no letter next to it at all. So standard form. So that's everything. How do you feel about that?